Welcome to section 1.3, Piecewise Functions. We're going to determine the intervals at which functions are increasing, decreasing, or constant. We're also going to identify and graph piecewise functions. The first thing I want to look at is an increasing function, and if a function is increasing, if you read it from left to right, and that's what the x of 1 less than x of 2 means, if you read it from left to right, then if this is x of 1 and this point up here is your x of 2, then the f of x sub 1 is going to be less than the f of x sub 2, which is your y value. So this is f of x sub 1, and this up here is f of x sub 2. Therefore, the function is increasing. Also look at the slope. The slope is increasing, so that means the function is increasing. Same idea with decreasing. Once again, if your x value, starting off from left to right, is less than, then the function will be decreasing because your first value will be greater than your second value, so therefore it will be going down, and that's where a decreasing function occurs. Once again, looking at the slope, it is the slope is decreasing as well, so that's another way you can look at it. A function f is constant on an interval if for any of the values x sub 1 and x sub 2 on that interval or in that interval, then your y values have to be exactly the same. So if this is x sub 1 and this is x sub 2, once again all those values of y are staying the same throughout that interval. Therefore, the function f is constant on that interval. So I have a graph here for you. Determine the intervals at which the function is increasing, decreasing, and constant. And we're going to do this in interval notation. And we're going to identify where is it increasing, decreasing, and constant. And so I gave you something that kind of gets all three aspects of it. So let's just start with the kind of left to right here. So as the graph starts, down here on the left-hand side, it is going down and left forever. So as we kind of work our way up the graph, it's increasing. The graph is increasing until about this point right here. And so the graph is increasing on what interval? Well, from negative infinity, these are your x values. The function is increasing when x is negative infinity all the way up to, as x gets close to 1, and then up to right here, 2. And so it increases from negative infinity to 2. And then what happens? Then it starts to decrease. The y values go down, and then they stop at this point right here. So they're decreasing on the interval from 2, and make sure you're writing the x value. So from 2 to 4, the function is decreasing. So we're talking about the function. The function is the y value. So the y value increases from negative infinity to 2 and decreases from 2 to 4, and then from 4 on to infinity it stays constant. And that's how you identify whether a function is increasing, decreasing, or constant. Once again, these are your x values that you're writing down. You're saying the function is increasing, which is the y value. The function is decreasing, and the function is constant on these x values. Okay. Kind of going on to the next thing, relative max and min. I got a graph on here just looking at points at which the function changes its increasing, decreasing, or constant behavior. So as you're looking at this graph, as it increases, it gets to this point, and then there's a change. So it's increasing, then it starts to go down, and so now it's decreasing. Well, at this change point right here, that's called a relative max. Same thing happens here. Now it starts to increase again, so the function is increasing. So it went from decreasing to increasing, so where that change occurs, there's a relative min. And then now on this one, it goes from increasing to decreasing, and at that point there's another relative max. So anytime there's a change in the function in terms of increasing, decreasing, or constant behavior, there's a relative max or min on there. Also, once again, think about your slope. Your slope's increasing, now it's decreasing. There's a change, and that's where those relative max and mins occur. A couple of quick definitions. Continuous, graph is continuous. There are no breaks. Basically, an easy way to say this, you can trace it without picking up your pencil. If you ever have to pick up your pencil, even for a single point, it's no longer continuous, it's discontinuous. So as long as there's one break in the graph, then it is discontinuous. So we're going to look at piecewise functions today, and some of these will be continuous and some of them will be discontinuous. So a piecewise function is a function that is defined by two or more equations over a specific domain. So what we're going to do is I got a 10 by 10 graph on here. I got a piecewise function. You can see there's two parts to it. So it's really like you're graphing two parts, but it's still a function. So it's still going to pass the vertical line test. No x value is going to go to more than two y values, or more than one y value, sorry. And so we're just going to graph these. I'm going to and then we're going to talk about the intervals as to where it's increasing, decreasing, or constant. Now in this first one, if you look here, x must be less than 0 when you graph this function. And on this one, it must be greater than 0. So I'm going to draw to kind of help us out here. Make sure I got the right one here. Okay. I'm going to draw a line at x equals 0. And that's going to split our graph up into these two pieces. So with the 5x plus 2, we're only going to graph values that are less than 0. Okay? But we've got to at least start at 0. And so we'll include 0, but we'll use an open circle to indicate that it's not part of that linear function. So 5x plus 2. You can do this a couple of ways. You can use a t-chart. You can just plug in values, 0, -1, -2, -3. You could graph the line and then just take off the part that you don't need. I'll use kind of just a quick t-chart to kind of show you here. So 5x plus 2, knowing that I can only use 0, -1, -2, and since it's linear, I really only need 2 points. So if I plug in 0, 5 times 0 is 0, 0 plus 2 is 2, -1 would be -3, -2, that would be -10 plus 2 is -8. So you can see they're increasing, actually decreasing by 5 each time. So at 0, 2, we're going to have an open circle right there because it's not actually part of the function because x is less than 0, it's not included. And then at -1, -3, and then at -2, -8. And so we have a line. Should be using a straight edge here. So we have a line going down. Those are values that are less than 0. Okay. Now we're going to graph values that are greater than 0, but for a different function. So once again, we could do a t-chart for values that are greater than 0, including 0. Once again, knowing it's going to be an open circle. So if you plug 0 in, you get an output of 2. If you plug 1 in, now 1's not really a good choice because 1 times the fraction 1/3 is going to give us a decimal. So I'm going to go back and fix that and choose values that are going to give us nicer numbers, such as 3. So if I plug in 3, I get -1 plus 2 is 1. If I plug in 6, I get -2 plus 2, which is 0. So you can see the pattern. This is once again linear. So at 0, 2, once again, that's a point, but it's not equal to 0, so it's going to be an open circle again. It's already an open circle. It stays an open circle at 0, 2. Then at 3, 1. And at 6, 0. And there's my other linear equation. And so there's my piecewise function. I'm now actually going to get rid of, maybe, if I can do this, yep, get rid of that line. That was just to kind of help me see that break. And so is this still a function? Yes, it's still a function. It passes the vertical line test. is it continuous or discontinuous? Discontinuous. There's a break in the graph. Even though it's a single point, there's a break in the graph. And then let's go back and name the intervals where the graph is increasing, decreasing, or constant. Well, I'm working from left to right. This graph is going up. It's increasing, so it's increasing from negative infinity up until, what's the x value? The x value was at 0. And then at 0, x equals 0, it starts going, the y value starts going down, so it's decreasing on the interval from 0 to infinity. And so that's a piecewise function. Once again, talking about increasing, decreasing, constant, and also is it continuous or discontinuous. Let's take a look at another one here. If you want to pause and try to do this on your own, you're more than welcome to. This one is 3 parts to the piecewise function. So let's go back and get these kind of 3 parts. So what I want to do is I want to do a kind of boundary line, vertical line at x equals -1 to break up my piecewise function. And then there's another one at 1, very small area right here. So we're going to have 3 parts to this one. The first one, x squared plus 3. We're going to choose values that are less than -1. So for this one, we'll do -1, -2, -3. Once again, -1 is not included. It'll be an open circle. -1 squared is 1. 1 plus 3 is 4. -2 squared is 4. 4 plus 3 is 7. And -3 squared is 9. 9 plus 3 is 12. So we won't be able to fit that one on the graph, but we can get -1, 4. Open circle, not included. -2, 7. And this is a parabola, it's not a line, so don't draw it as a line. And then 3, 12 is somewhere up here, so graph that. So there's the first part. The second part, we're only going to do values between -1 and 1. But pay attention on this one. You do have equal to, so these will be filled in circles indicating that it's part of your domain. So we're only going to do values -1 to 1. So -1, 0, and 1. So -1 times -2, 0 times -2, and 1 times -2. So this is going into your second one. So this one is the x squared plus 3, and this one's into -2x. So we'll plot those points. So at -1, 2, it's now filled in 0, 0, and 1, -2. So there we go. And then the last function is a square root function. So the square root of x plus 2. We're going to graph values that are greater than 1. So 1, 2, 3, and so on. So at 1, square root of 1 is 1. 1 plus 2 is 3. I don't want to do the square root of 2 or the square root of 3, so I'm going to go back and fix that. I want to do the square root of 4. Square root of 4 is 2. 2 plus 2 is 4. And then 9, square root of 9 is 3. 3 plus 2 is 5. So once again, it's not equal to, so at 1, 3, we'll have an open circle. And then at 4, 1, 2, 3, 4, 4, 4. And then at 9, 5. And once again, it's not linear, it's a square root, so it has a little curve to it. And so there is your piecewise function. And I'll get rid of these again, and so you can see without those lines. And once again, it's still a function. There's, it passes the vertical line test. You're just graphing in different sections of your domain. So is this one continuous or discontinuous? Well, you can see all the breaks in the graph on this one, definitely discontinuous. And as we read from left to right, what is happening? Well, this one is going down, so it's decreasing. And even when it has this break in the graph, it continues to decrease. So it's going to decrease from negative infinity all the way down to x equals x equals positive 1. And then you have this other break, and it goes back up here, and now this graph is increasing from 1. So it increases from 1 to infinity. And so once again, there you go, another piecewise function. And so as long as you get in the habit of breaking that graph up and just graphing each individual piece, a lot of times by using T-charts, you can also use transformations. It's just sometimes difficult because you're only graphing part of it. And then I have one more on here, so let's go ahead and knock this one out. And once again, if you want to pause it and then check back and see how you did, you can. Now this one goes from negative, let's see, x is less than negative 2, so we'll get that line in there, between negative 2 and 2, and then greater than 2. So let's go ahead and get started. Alright, the first one is linear, so we'll do negative x plus 2. And I continue to use T-charts, but like I said, you don't have to. We want values that are less than negative 2, so negative 2, negative 3, negative 4. Plug those in. You get 2 plus 2 is 4. Negative 3, the opposite of that would be 3. 3 plus 2 is 5. And the opposite of negative 4 is 4. 4 plus 2 is 6. So at negative 2, 4, you're going to have an open circle. Negative 3, 5. And negative 4, 6. It is linear. Okay. And then the next one, it's just f of x equals 4. And that's constant, so that's going to be a horizontal line at 4. Now, this one does include negative 2 and 2. So your output is always going to be 4. So you're going to have a point at negative 2, 4, which is now going to fill in that circle. So it's no longer an open circle, it's a closed circle. And then it goes across, and then at 2, it's also filled in. Okay, so far right now this one's continuous. And then now we'll do the x squared. And the x squared, we want values that are only greater than 2. So we'll do 2, 3, and 4. 2 squared is 4, 3 squared is 9, 4 squared is 16. So at 2, 4 we would have an open circle, but it's already closed from the previous part of the piecewise, so it will not be open, it's still closed at 2, 4. And then at 3, 9 you'll have another one, 4, 16, obviously off the graph, but this is a quadratic, so make sure you get that curve in there. And so now when you look at this one, is this continuous or discontinuous? Well, this one is definitely continuous. There is no break in the graph of the piecewise function. It was all kind of connected together. And if we look at the intervals, increasing, decreasing, and constant, let's go through here. Let's work left to right. So on this one, it's going down. Your y values are decreasing. So it's decreasing from x is negative infinity all the way until x is negative 2. And then from negative 2 to 2, it's constant. So from negative 2 to 2, it's constant. And then from 2 to infinity, it is increasing. Okay, and so there you go. That is piecewise functions. I did 3 examples for you. We talked about increasing, decreasing, and constant. Once again, the y value is increasing, decreasing, constant. What is the interval for x? And then is it continuous or discontinuous? On your homework tonight, please make sure you follow these directions. You only have 41 to 48 tonight. You're just going to graph, you're going to determine the intervals and the continuity, just like we did on these 3 examples. You graphed it, and let me get rid of my lines here. You're going to graph it, you're going to identify continuous, discontinuous, and the intervals. So once again, exactly like these 3 problems we did in the notes. Thanks.